So we're going to have a look in this tutorial at how we can work out an area between the curve and the x-axis on the GDC. So this is the question we've got here. We've got a function y equals e to the x multiplied by cos x plus sin x, only defined between -2 and 3. And we've got to try and find the area enclosed by the curve, the x-axis and the y-axis. So I've shaded what that would look like. If you imagine trying to have something enclosed, that means it's got complete boundaries, it's not open in any way. So if you look at the curve, the bit that we're looking for is the bit that's sort of enclosed, fenced off by the y-axis, the x-axis, and the curve itself. So that creates the shaded bit that we're looking for here. So let's have a go at doing that then on our GDC. We open up a new graph page, and we'll need to do e to the x, and then get out of the power, multiplied to cos x plus sin x. And we can see it looks similar to what we had in the original picture. Obviously we only had a snapshot here as opposed to having all these bits over here. So we could, if we wanted to, change our window now, just to zoom in a little bit and go only between the -2 and 3 that this is specified for. Now, remember, this is the area that I wanted to try and find. So the bit that I'm now going to need to go on to is menu, analyze graph, and the integral to find an area. The only problem I've got if I do that is when I do the integral, it's going to ask me where I want my start point and where I want my end point to be. The end point is a bit of an issue at the moment because I don't know exactly where that part needs to be, and I must be absolutely precise when I do that. So if I go on to menu, analyze graph, and now do 0, then what I can do is click on the left and the right hand side of this graph, and it will pinpoint exactly where that 0 is. I don't need to do it on this side because it's starting at 0, so I can type that in easily. At this point here, I wouldn't have known otherwise. So now I can go back, menu, analyze graph, and integral. For the lower bound, the furthest left bit I want it to be starting here. Now I don't want to be imprecise with it. I could do the intersection point, but I also know that it's at 0. So you can just literally type in 0, enter, and it will snap to that point. Now I want to make sure I pinpoint the upper value over here. So this is where the point I've already found is useful, because I can now click on that intersection point and it will do it exactly in the place I want it to be, and I can see now that the area was 7.46 to 3 significant figures.